Okay, and if you need any encouragement to stick to your 1 minute, I'll remind you that you are standing between a room of astrophysicists and their coffee. So take it away, Bob. Oh, yes. Yeah. Oh, and do you want to take the mic as well?
I don't need a mic, but
you do.
Okay. Okay, I'd like to talk about some recent work carried out a couple of years ago with Krista Smith and an undergraduate student at Stanford's, Celia Tandon. Has to deal with 3 mysteries that appear when we study the high frequency QPOs in black hole accretion disks. Why are we interested in the high frequency QPOs? Because they're the only quasi-periodic oscillations which appear to be stable. And so they could act as good clocks just above the horizon of the black hole. Okay? So the first thing we investigated, whoops, sorry.
Yeah, just I don't put the mouse. You've got about 30 seconds.
First thing we investigated was supermassive black hole sources in this paper with Krista. And we found that they all lay in this plane. This is the plane of QPO frequency times black hole mass versus black hole spin. Here's what was the observed sources. Here are all the theoretical models up here, significantly higher than the observed sources down here. So we clearly need more observations. They've been very, not coming in very fast lately to understand this discrepancy in the supermassive black hole QPOs. Second investigation with Celia was a computer simulation of one mode of oscillation of a black hole accretion disk. And we had to vary the damping rate because turbulence does not damp the mode, it only drives the mode. And we know in the sun, the P modes are driven by convective turbulence, but we don't know what the damping is. So we investigated different damping rates. Then we went to the next mystery. Computer simulations in the past have never produced the observed QPOs, high frequency QPOs. Why is that? Well, we looked at how these modes evolve in the presence of high dissipation and found that, as Reynolds and Miller did a few years ago, you have to begin from high amplitude, and then you can see the modes on the way down as they're damped toward equilibrium here. So we're trying to encourage various computer simulators to carry out this investigation.
Thank you, Bob. If you want to find out more, the posters are upstairs.
Oh, hello. Okay. Hi, I'm a postdoc here at Stanford, and I'm just going to talk about a galaxy cluster in the Relax galaxy cluster. So basically, there's a agent feedback that's happening in galaxy cluster, and these are the 3 examples of galaxy cluster that we have been using to try to study the feedback and how it's mean for the galaxy cluster evolution and formation. Yeah, you can go see it upstairs.
Thank you very much.